Zaharis here. So today we are doing Labshock demo with Splunk. But first we are jumping into this topic. Who don't know what is Labshock and how to use it, you can go into the website. We have new domain labshocksecurity.com. Here you can find all the information about the problem, why the Labshock was created, and what is inside, which services are running, and also step-by-step guide what to do to up and running this lab. And Labshock is a hands-on OT cybersecurity lab designed for security professionals, engineers, and researchers. And it provides a really ready-to-use environment which you can install in 10 minutes and have the protocols such Modbus and simulate the techniques and defensive strategies what you have. Also join our Discord. We have a lot of people there and you can ask any questions what you have. How to install? You can go into GitHub. You need to read first this README file, for example, network diagrams, what requirements you need, about the trial license, how it's run. And for install and update, you can use a quick start guide. Here you can find the installation for Debian and Ubuntu. Also, there is a video how to do it, so please check it and install. And use official installation guides because they have up-to-date information how to install, for example, packages and also Docker installation. You can use or a Git installation. There is also guide. And after that, so there is a few commands to install it. And we can go into the local host. In my installation, it is a little bit different. User and password is Labshock. And you will see this portal page. What we have here, this is the different tabs, which name OT, DMZ, and IT. They are sitting, let's start from this network diagram. This is a physical diagram for the network, and here we have OT, what is down of the firewall. So we have a PLC, our main, let's say, source and main thing what we need to protect. It is sitting on the level 2 network in the level 2 switch. After that we have level 3 switch where we are putting our SCADA with 3.20 IP address. This is network level 3. We are putting here engineering workstation to do some programming and maintenance the PLC and SCADA. And for detection, we have this collector, what we will talk today, how to collect all the data from this area, from the SCADA, from the PLC, from the IDS, which is sitting and listening the traffic. And after that, we have a firewall. I put it onto the center because it is maybe not one of the most important, but it doing segmentation and creating such networks as DMZ. And here we are putting another collector, DMZ collector, which is collecting data from the firewall and additional sources which are on the DMZ zone. And after that, new thing, we have an IT zone here on the up. Some let's say, network with now with one service with the SIEM, and here we are putting a Splunk as a first SIEM. Why Splunk? Because people choose the Splunk, and we decided to move from the first one as a Splunk SIEM. And the diagram how we are collecting this. So we are utilizing the syslog as a most easy and lightweight solution to collect logs. So we have a PLC sending logs into our collector. In our case, OpenPLC was rewritten and added the functionality for security, let's say, features for logging. We are configuring the PLC sending logs to the collector. The same from the SCADA. So it was rewritten, and now it supports the syslog to the collector. The same way you can collect syslog from the engineer workstation and syslog from the IDS. So all the logs from the OT networking are collected into the collector. After that, this collector is sending data into the DMZ collector, which is sitting on the DMZ network. And this DMZ collector is sending logs into the same. So this is our logical schema for today and for Oil Springs network. And how to configure. The same thing. You are going into the wiki, and there is a SIEM service. Again here, and all the information what I will talk today is here. For example, collector setup. You need to set up collector. You need to put up sources, also settings, and the SIEM side. We will walk through all these steps now, but if you have some questions, you can go here and check what to do. Yeah. Okay. So now we can jump into the portal and see these OT services. For example, let's recheck the SCADA service so that everything is running, everything is working. We can check PLC, login, OpenPLC. Recheck please the status that it is running. Sometimes it's on the stop when you have some problem with performance. You can go into the monitoring page, check that everything is blinking, and you can start and also stop the pump from the PLC. Yeah. And the one thing in settings, now we have this security tab, let's say enable syslog server. And in this case, we need to put our OT syslog, which is 3.40 with the port. You need to save the changes and restart the service because it is not applying on the fly. We will focus today on the PLC service and collecting logs from this service as a starting point. And of course, as a main service for collecting. Okay, we can close and let's go into our collector. I'm not going deeper about the SCADA, PLC or engineering workstation, how everything is connected, what you need to do. If you need some information, please check another videos and check the GitHub wiki page. I have also the labs about how to configure the SCADA or PLC. So please check these labs and you will pretty much find all the information. Okay, now we can go into the collector service and you can see some logs from the OT network. Let's write login. As you can see that main PLC we have attempting to log in. So it is exactly going from the PLC that someone trying to log in. And also we have login success for user OpenPLC. In this case, we can detect all the logs from the PLC. Why this is important? Because you will control your PLC, and at least your engineers and your personnel will know that this PLC is under the monitoring and they will not change the projects on the fly. This is a very big advantage of monitoring the PLC. Yeah. And what next? This collector has a schema in this way. So from the PLC, logs are going into the collector. Now we need to resend these logs into another collector. Why? Because we can't send the logs directly from the collector into the SIEM. It is wrong way, so please don't do it. You need to resend through the DMZ. We are going into the settings, and here first of all you need to put a collector ID to identify that this is OT collector, and we need to enable syslog server. In our case, this is IP address from the DMZ zone. This is a DMZ collector. Yeah, okay. Everything is clear. We have messages from the PLC and we need to resend these messages into our Splunk instance. Next, you can go into the DMZ zone. Here we have also some services. For example, Firewall. You can configure the rules, check the connections, and inside the settings you have also syslog server. In our case, this is DMZ collector, not OT collector, but DMZ collector from the 172 network. Yeah. If we are going into the schema, this firewall is sending logs into the DMZ collector. Now let's go into this DMZ collector, and inside this DMZ we can see that someone reading the firewall rules. Someone access the connections and check the connections. This is logs from the firewall. We will not go into the firewall review and firewall recheck and monitoring. I only show you that these logs are going into this DMZ collector. And what's important, in this DMZ collector, you need to add the OT collector and put the type as a collector. That DMZ collector knows that I have a collector and this collector is sitting in this IP address. Why it is doing to have this resending the logs. If this DMZ collector knows about this collector, it resends all the logs and working as a proxy for our log collection. It is a normal way for all the collectors. If it's a universal forwarder for Splunk, you can do the same way. Yeah. Everything described on the wiki page, so please recheck it. Next, on the settings, we are putting a collector ID and also a server IP as a Splunk instance. So this DMZ collector will send all the logs to the IT network. This hop. DMZ collector is sending logs into the Splunk. Okay, so now we can go into the portal, and there is one more tab, IT tab. And here, this is new thing. In this version, we have a SIEM service. SIEM, let's say fast SIEM. And this is a Splunk service. What you need to do, you need to only push the start button. After that, wait 5 minutes, because first start will download the Splunk image. It's about few gigabytes, and run the Splunk service. For running the Splunk, starting the Splunk service, it requires 2 minutes. After that, you can click connect button, and here we go. This is the Splunk Enterprise. What you need to do, admin, Labshock, sign in, and yeah, this is a fresh installation. So today we are doing from the scratch all these, let's say, trashy things to configure the Splunk. Got it? This is the last version for recording 10, so it may be something new here, but let's see. And what we need to do, we need to go into the settings, data inputs. All these things is also in the wiki page. We are doing now this add data sources. Okay, we need to put UDP, and we need to new local UDP. For here, port 514. You need to select sources, syslog. Submit. That's all. So this is all configuration for the Splunk. So push the start button, go drink some coffee or whatever. After that, connect. After that, settings, add sources, and start searching. You have source UDP, source type syslog. This is the search for the Splunk. And now let's go one more time and try to log in into our PLC. Let's say 123, 123, login, bad credentials. Try again. Okay, let's try again. 123, 123, login. No, sorry, but not today. After that, you need wait maybe 10 to up to 1 minute that logs are ingest into our Splunk service. Go back here, search, and voila, we have these logs on the Splunk. It is the, let's say, the search, and this interface is pretty much similar for all the SIEMs. Maybe something is different, but you have some search button, some fields at the left, and some data into the center. The cool thing from the Splunk, it is easy to learn and easy to understand this interface. Why? For example, we have type the PLC. You can add this into the search and you have type PLC. You will have all the logs from your PLCs. One thing, Splunk instance is automatically parse the JSON, what we have here. And our collectors are sending data in the JSON format, and this is why we have this collector ID, count, and data. And one important thing that we have this type and, for example, collector ID. These fields are coming from the title collector, and this title collector is enriching the data with the type. So you can at least filter and check all the logs from the PLCs. Or you can filter logs from this collector. Okay, let's see what we have. We have login failed, login attempt, and some more login attempt. And now, what you can do, let's start from. Let's save the easiest, let's say, alert you are putting into the searching. This is attempting login, and you can save this as event is alert. Yeah, maybe it's not important for you, the super important, but login to PLC, it's always important. We can make the alert. You can put the name, for example, PLC login attempt and description. For now, we are going into some simple description that attempt login to PLC. This description is going into your SOC analysis, analysts and people who want to understand what is happening. So you need to describe it fully and at least put some information. We will do it on the next alerts, but for now, let's put it as simple as possible. Yeah, we can put real time. This one is about is it running every hour, day, week, months, or real time. For real time, you have some performance issues for that. So don't put everything in real time. If you have your teams working for login into the Splunk once per day or once per week, put exactly this one. If you have your capacity to check the Splunk once per day, put one per day. If once per week, put once per week. Of course, if it's super important and you have a lot of analysts, put real time. And we can add the actions, triggered alerts, and we can put severity low. Put save, view alert, PLC login attempt, enable yes. And now when we, let's say one more time going into the PLC and we get into this page, we even don't try to log in. We are going here, and you can go into triggered alerts. wait a little bit. And the same thing can be done, let's say, I'm showing the login attempt because maybe you don't have another logs from the login and you need to use this one. Of course, the best one is that successful login and fail login, but this is only as example as we create a triggered alert. So this is the logic of this Splunk. You have the search, you find some useful events inside your data, and you are putting this alert as a PLC login attempt. You can go and view results, and it will show you that something is trying to log in. Yeah, okay, so let's go back into our search. No thanks. We are putting this source UDP to find all the logs from our PLC. And of course, you can find this logging success. This one will be a real login into your PLC. You can do the same, save as, alert, and put it as a failed login. And the question is how to create these alerts, where I can find them. For that, you need a database, a knowledge database for known alerts. The good news that here, of course, we have a MITRE ATT&CK. You can go here and at least create some basic stuff. For example, disclaimer, you are running this lab at your own risk. Labshock is intended for educational and lawful testing in isolated environments only. The author is not responsible for any damage, data loss, legal issues, or misuse of this tool. Okay, let's start from, for example, change operating mode. In this thing, we have a stop. The PLC program is stopped. Is it critical? Yeah, it's critical. So let's go into our PLC and stop the PLC. Someone log into the PLC and stop the PLC. It can be engineer or it can be adversary. So no matter, we need to somehow detect this. In this case, we are stopping the PLC. We are going back into our search, deleting this one, all logs. That's a PLC. And we have this PLC stop. PLC stop. We have one event. Cool. We are going save, alert. And now PLC stop. And here you can write exactly this one. For example, technique, we copy this technique, putting it here, putting this one, and you can name it change operating mode, and maybe some description as this one. Yeah, and in this case, someone, it can be human or it can be AI think or whatever, he understand that, yeah, this is technique, I can go into, you can put it as a MITRE ATT&CK. Yeah, technique this one, change operating mode, and now if you are going into Google or whatever, you will find all the information what happened. We are putting one more time, real time, per result. This one configurations, what is doing what, please go into Splunk website. You can find everything about triggered alert. Check the version of the Splunk and time, fired alerts, and blah blah blah. So you can find all the information on the Splunk. I'm not going here deeper and describe everything. So please, if you have some question, go into the Splunk website. Yeah. Okay. Now we are putting a real time. We are putting action at triggered alert, and it is high for us. So if PLC is stopped, it is maybe not critical, but it is high. Save. View alert. PLC stop, rechecking that everything is okay. Yeah, go one more time into our PLC, start it back. Running, good, and we can stop the PLC. Let's go. And the way how you can check that logs. First, you need to go into the collector, check the PLC stop. Please first recheck that this event is inside your collector, and after that, if everything is fine, you will find it here. No. Search history, this one, add to search. This is a default search for syslog. We can one more time add the type. I'm always adding the type because maybe the PLC stop can be not on the PLC but somewhere else. You need some more specific searches. The best one is code. If you don't have code, you need to make some type or name or collector ID or whatever to remove false. Okay, so PLC stop is here, and now we can go into the triggered alerts and check is it there or not. PLC stop, severity high, cool. View results, yeah, PLC stop. And in this case, you will find, first of all, the raw data, why this alert is triggered, and this alert inside your, let's say inside your dashboard, inside your really critical alert. And you can at least see this information and see this SQL search. In general, this is all about how you can create. So now you have all the tools to make this process. You have the data from the OpenPLC, you have collectors, and you have Splunk. So you don't need to configure all this stuff. So you can only play with this one, ICS metrics, and detect something. And maybe one more example, not from the PLC, but something from the network. Let's go into our ICS matrix and check one new thing that was introduced in latest version for 1 second. It is something command. That is unauthorized command message. This one. Advertisers may send unauthorized command message to control systems. You are going here. Of course, you can check the examples. Who did this one? So, and also targeted assets. What can be targeted? Mitigations and detection. For detections, we are going into the network traffic and monitor for unexpected ICS protocol commands. And let's go in and detect it. First of all, we have, I will close everything. This one, close. Trigger alerts, one will closed. Let's recheck one more time. This PLC, we analyzed that we can collect data from the PLC. This one from the IDS, let's recheck the network traffic, that we can see there something from your IDS. Let's go into the IDS service, into the packets first. We can see that packets is here, and also you can see the raw syslog data from in the network PLC start. So this is when you sending the unencrypted traffic inside your network, and this is how you can sniff and detect it. Okay, packets is here. We can go into the messages. Let's clear the messages. That thing will be here. And what we can do. So we can go into the pentest service. First one, we need to detect our IP address, our PLC. Host is up. Yeah, I know that this is 2.10. You probably don't know, so you need to recheck it. Host is up. Next one, you will go into the host scan and also recheck the ports, range. TCP host is up. 2.10. Of course, it's not up because we stopped the PLC. We need to go into the PLC and start the PLC. Running. Okay, cool. Going back, recheck one more time. Bumps, yeah. 502 is open. So something is sitting inside this port. Yeah. We know that this is Modbus. We are going into the Modbus tab. This is the commands for the Modbus. It is not something exploits or something bad. It is a legal, let's say, client for the Modbus. We can read and write. You can find a lot of these clients on the network, so it's some normal thing. 2.10 in Tidal Collector, it's only making your life much more easier. So read coils, run, and you can see the coil statuses from the PLC. I'm not going deeper what is it and how it's connected. See another videos and check the another labs. For now, we have that in address 0 we have true. And of course, let's go into our network swiftness. What we can see here. First thing, what we see that source 3.30. In our case, if we will open this, it is not inside our network diagram. So it's something new that appears inside our communications. And network swiftness detects this as something wrong, something new, and it shows you new connection detected from 3.30 into 2.10. And the next one, ICMP. So it detects new protocol from 3.30 into 2.10. This is when we perform a scanning with Pentest Fury. After that, this one is not interesting. This is not interesting. It is a reverse packets from our PLC. This is interesting, that new protocol detected, Modbus. Modbus TCP detected from 3.30 into 2.10. This is exactly when we send a read command. It detects as a new protocol. And this is our unauthorized command, new Modbus command detected, read coils. So in this case, network swiftness detect the new Modbus command. And as you understand that it is it is inside search type NS. We can add type NS, not the PLC, and you can see that exactly the same messages from the IDS are coming into the Splunk, and you can play with these messages. We need this. Going here, new Modbus command detected. Bumps, and we have these read coils from the source 3.30 into 2.10. So if something sending some command first time from source into the destination, it detects as a new Modbus command detected. What we can do, of course, we can save it as an alert. We can name it IDS new command detected. Detect new Modbus new. Let's write Modbus. New Modbus command detected. Detect new Modbus from the source. And one more time, you are going into the, sorry, not triggered alerts, but description for unauthorized command message. You can put technique as this one and make some description. Yeah. Advertisers may send unauthorized command message to control system, blah, 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 function, or without logical precondition to trigger their expected functions. Put it here. Real time. One more time, I am putting real time only to this demo. Don't put real time for all the alerts, it's not necessary. The logic from the Splunk that it performs the searches to your database. If you put real time, it will run these searches real time on the memory, so it is a performance issue. Add action, triggered alerts, maybe some high thing, but of course you need to understand that it can cause you a lot of false positive. All the IDS things are by default go into the false. So, but it's let's say it's an IDS problem to remove this false. Yeah, it is not our today topic. IDS new Modbus command detected. Yeah, let's go back into our pentest. Yeah, okay, something read coils. Now let's recheck the writings. The 10 port address 0 value 1. Sorry, 0. To show you what is happening, we can go into the SCADA. This one pump. I'm not touching it here. It is running. The flow is going through this pump. Everything is okay. Flow rate is okay. Operator is happy and drinking some tea or coffee, maybe beer. Write a coil. Coil 0 writes successfully to address. Now going back, pump is not working. Flow rate is down, your graph is down, and the worst thing that you can send this command and operator can sometimes could not see this in their interfaces. It can be hidden. But in our case, to visualize it, pump 1 is off. And what you think? We are going into network Swiftness. New Modbus command detected. Now it is not read coil, but write single coil. Yeah. And what we can expect that it is inside our triggered alert. Yeah. IDS new Modbus command detected. You can go view results. Bumps this raw event is inside the Splunk. And in this way you can practice, learn, and say that I know that the Splunk place. Don't ask me some stupid questions. Yeah, and Splunk will give you a lot of how to analyze the data, because it is, yeah, it may be not a free, but I think it is the best starting point for everyone who don't know what is SIEM and how to do this. Okay, so to summarize everything, you have this Labshock GitHub. Please put some star if you enjoyed watching this video, it helped me. You can read everything from the services. What is PLC? What is how to log in? What is support this PLC? SCADA, etc. After installing on the wiki, after installing, you can go directly into the services, and in our case into the SIEM service. Read this page please before jumping into something, discovering the Splunk. After that, go maybe into the portal page and configure the collectors, configure the sources, configure the DMZ collector, and run the Splunk. Log in into the Splunk, configure the Splunk, and try to go deeper inside the logs and the logic, the alerts, and try to cover something from the MITRE ATT&CK. Yeah, that's all for today. So thanks a lot and have a nice day and weekend and night, whatever. yeah, here's a her. So subscribe, put like, you know what to click. So thanks a lot. This is the Labshock, and many things will happen in 1 month. So stay tuned. Thank you. Bye.